Hello students, welcome to all of you in SAM Alchemy classes. Today we will discuss about hydrocarbons, class 11, unit 13, hydrocarbon. Hydrocarbons. What are hydrocarbons? It's clear from name hydrogen and carbon. Hydrogen and carbon. So those compounds that have only two components, hydrogen and carbon, are called hydrocarbons. So hydrocarbons have composition of carbon and hydrogen only. So those compounds that have only carbon and hydrogen as components are called hydrocarbons. Now for hydrocarbons we will discuss first of all classification of hydrocarbons. Hydrocarbons are classified as saturated hydrocarbons. Saturated. Next, unsaturated. And next one, aromatic. So hydrocarbons are categorized as saturated hydrocarbons, unsaturated hydrocarbons, and aromatic hydrocarbons. So first, saturated hydrocarbons, when there are all the carbon bonds are single bond. All the carbon bonds are single bond. They are called saturated, single bond. They are called saturated hydrocarbons. Saturated hydrocarbons are again categorized as alkane and cycloalkane. Here alkanes are aliphatic. Aliphatic means what? Aliphatic means open chain. Nomenclature में discuss कर चुके हैं. Open chain with both the ends are open, while cycloalkanes are carboxylic ring structures like this: cyclopropane, cyclobutane, cyclopentane. So these are saturated hydrocarbons but ring structure, while in alkanes, that is aliphatic hydrocarbons, these are straight chain or open chain with both the ends are completely free to each other. So saturated hydrocarbons are classified as alkane and cycloalkanes. Alkanes are also called as paraffins. Next is unsaturated. Unsaturated are categorized as alkene and alkyne. What are alkene? In nomenclature discuss कर चुके हैं. When there is ene, it means carbon double bond carbon is present. At least one carbon double bond carbon containing hydrocarbons are called alkenes. In open chain structure, that is aliphatic, both the ends are free to each other, like CH2 double bond CH2, like CH3 CH double bond CH2. Both the ends are free and one double bond is present, so alkene, unsaturated hydrocarbon. Alkyne means triple bond when there is at least one triple bond carbon is present. It's a category of alkyne unsaturated hydrocarbon, like the CH triple bond CH, like CH3C triple bond CH. This is ethene, alkene, propene, alkene. This is ethyne. This is propine. This is cycloalkane. And this is alkane. Alkane has general formula CnH2n plus 2. Next, aromatic. Next are aromatics. Aromatic hydrocarbons are a special type of hydrocarbons. A special type of हाइड्रोकार्बन्स. स्पेशल टाइप क्यों है? एक तो ये रिंग है जैसे कि साइक्लोएल्केन है. नेक्स्ट थिंग, इनमें मिनिमम कार्बन जो है वो 6 है. 6 कार्बन, मिनिमम कार्बन 6 होते हैं. तो इसका बेस होता है बेंजीन रिंग विथ 6 कार्बन, where double bonds are in alternate order. So in all the aromatics, double bond will be in alternate order. जितने भी एरोमेटिक है वो स्पेशल टाइप ऑफ हाइड्रोकार्बन्स है, क्योंकि रिंग स्ट्रक्चर में मिनिमम 6 कार्बन की रिक्वायरमेंट होती है और इसमें अल्टरनेट ऑर्डर में डबल बॉन्ड्स होते हैं. और जो इसका बेस कंपाउंड है उसमें 3 पाई बॉन्ड्स जो अल्टरनेट में प्रेजेंट होते हैं. एंड इट इज बेंजीन रिंग. दिस इज स्ट्रक्चर ऑफ बेंजीन. ये बेस होगा. इसके साथ साथ जैसे जैसे स्ट्रक्चर्स में रिंग्स ऐड होती जाएंगी, नेक्स्ट कंपाउंड्स का फॉर्मेशन होता जाएगा. लाइक नेक्स्ट इज विद डबल रिंग स्ट्रक्चर. दिस मिनिमम 1 रिंग इज मस्ट विद alternate order double bonds, and 1 ring contains 6 carbon. Now here double bond in alternate order. So double, single, double. This will be the structure. This is called naphthalene. Like this एक एंथ्रासिन भी होता है जिसमें 3 बेंजीन रिंग स्ट्रक्चर्स होते हैं. 3 बेंजीन रिंग स्ट्रक्चर्स, बिकॉज एरोमेटिक के लिए मिनिमम रिक्वायरमेंट्स 1 रिंग विथ 6 कार्बन होती है. ऑल्टरनेट में डबल बॉन्ड्स होने चाहिए. रिजोनेंस, ड्यू टू रिजोनेंस ये मस्ट है. डबल सिंगल डबल, सिंगल डबल, सिंगल डबल, डबल सिंगल डबल. दिस इज एंथ्रासीन. So benzene aromatics are a special type of hydrocarbons where resonance is present and the base compound has minimum 6 carbon with 3 double bonds, pi bonds in alternate order. These are ring structures. So next is, after classification of alkanes, nomenclature we have discussed. Nomenclature ऑलरेडी मल्टीपल सेगमेंट्स में उसको हम डिस्कस कर चुके हैं. नेक्स्ट इज आइसोमेरिज्म. तो इसकी आइसोमेरिज्म में कोई फंक्शनल ग्रुप प्रेजेंट नहीं होता है, तो इसमें चेन आइसोमर्स के फॉर्मेशन होते हैं. उसमें एक सिंपल एग्जांपल ले सकते हैं, लाइक नॉर्मल पेंटेन. Normal pentane means all the carbon bonds are in a straight line without branching. 1 2 3 4 5. This is right. Normal pentane. Next is now branching 1 2 3 4 and 1 methyl is here. So since at second position methyl is attached, so now in common terminology it's called isopentane. IPAC name will become 2-methyl 2-methyl butane. 2-methyl butane. Here pentane, next is butane, and now next here methyl group are attached at one carbon. So total are 5. Now here 1, 2, 3, 2, 2 dimethyl. Commonly it's called neopentane. Neopentane. And now IPC name will become 2,2-dimethyl. 2,2-dimethyl propane. So in first one, longest carbon chain is of 5. In second one, but 4, and third one 3 pro. So there is change in the chain of compound. That's why these are chain isomers. ये एक दूसरे के चेन आइसोमर्स हैं. ये सभी एल्केन्स फंक्शनल आइसोमरिज्म शो नहीं करेंगे बिकॉज इनमें कोई भी फंक्शनल ग्रुप अटैच्ड नहीं है. नेक्स्ट इज preparation. Next is preparation. Preparation of alkane. Preparation of alkane. एल्केन के प्रिपरेशन के डिफरेंट मेथड्स हैं, जिनमें से फर्स्ट मेथड हम डिस्कस करेंगे रिडक्शन. रिडक्शन किसका रिडक्शन? अनसैचुरेटेड हाइड्रोकार्बन्स का रिडक्शन ऑफ अनसैचुरेटेड हाइड्रोकार्बन्स. अनसैचुरेटेड हाइड्रोकार्बन्स का रिडक्शन करेंगे लाइक एल्कीन एंड अल्काइन्स. Whenever reduction of alkenes and alkynes is carried out in presence of Raney-Nickell. What is Raney-Nickell? Alloy with 50% nickel and 50% aluminium. It's alloy of aluminium and nickel. Whenever Raney-Nickell is utilized as reducing agent for alkenes and alkynes, this reaction is termed as Sabatier-Sanders reduction. Sabatier-Sanders reduction. So note down this naming reaction, students. Sabatier-Sanders reduction is whenever reduction of unsaturated hydrocarbons, alkene and alkynes is carried out in presence of Raney-Nickell, that is an alloy of aluminum with nickel 50-50%, and here hydrogen gas is adsorbed, not absorbed, adsorbed on the surface of this Raney-Nickell. Hydrogen gas is adsorbed, and this adsorbed hydrogen gas reduces alkene to alkane and alkyne to alkene, then alkane in 2 steps. How this reaction is carried out, we will discuss. So Sabatier-Sanders reduction, that is in presence of Raney-Nickell. R CH double bond CH2, this is alkene reduction in presence of Raney-Nickell. Now one hydrogen to this carbon, one hydrogen here. Whenever one sigma bond, 2 sigma bonds will be formed, 1 pi bond get disappear. So here are CH2 single bond CH3. Single bond containing carbon bond is single. So alkane is formed from alkene. Since here Raney-Nickell is present, that's why this reaction is Sabatier-Sanders reduction. Here CH2 double bond CH2, real example with ethylene, is reduces the same catalyst. Here hydrogen to this carbon, formation of CH3 CH3. Next CH3 CH single bond CH3 single bond CH double bond CH2. Same condition, Rann nickel and aluminum alloys. Reduction, reduced by hydrogen. So one hydrogen here and one hydrogen here. Only hydrogen get attached with the carbon linked with double bond or triple bond. No effect on the rest of the group attached on both the sides of linked carbons. So here the attachment of hydrogen will be only on the double bonded linked carbons. So it will become the single bond and the final product formed will be an alkane. CH3 CH3 single bond, CH2 single bond, CH3 1 2 3 4 2 methyl butane. 2 methyl butane as a final product is obtained. If we take an alkyne, then reaction is carried out in two steps. For alkyne, RC triple bond CH. First, triple bond alkyne reduced into double bond, then after ultimately into alkane, that is carbon single bond carbon. That's why reaction is carried out in two steps. So reduction by hydrogen in presence of Rann nickel. Now one hydrogen to link triple bonded linked carbon, so it converts into double bonded unsaturated hydrocarbon. Reaction again continued until the double converts into single. So R CH2 CH3 and the final product alkane is obtained from alkyne within two steps. So real example is CH acetylene triple bond CH ethyne. IPAC name ethyne is reduced. Same condition. Now here CH2 double bond CH2. Next again reduction. So formation of CH3 single bond CH3 after two steps. Alkane ethane is formed. No any change in the number of carbon will be there. If you take 2 or 3 or 4 whatever the number of carbons in unsaturated hydrocarbons, the same number of carbon will be present in alkane. That is, it's not in the category of decarboxylation. The same number of alkyne will give the exactly same number of alkanes after reduction under Sabatier sentence. So next is in place of Rann nickel, platinum or palladium also be used because hydrogen gas get absorbed on the surface of platinum or palladium and it reduces the alkene and alkyne. It's called catalytic hydrogenation. Hydrogenation, addition of hydrogen, that is, it's a category of reduction reaction where hydrogen reduces the alkene and alkyne. Since the catalyst used are palladium or platinum, that's why it's the category of catalytic hydrogenation. Like CH2 double bond CH2 now reduced platinum or palladium, formation of CH3 single bond CH3. Same in the case of alkyne, CH3C triple bond CH, now reduced in presence of platinum or palladium. Again same condition, hydrogen get attached with the triple bonded. Reaction goes in two steps. CH double bond CH2 and the next step will be that results formation of alkane. 3 carbon containing alkyne is here propine. So 3 carbon containing alkane, propane is obtained as final product. In the category of reduction reactions, alkene and alkynes always results formation of alkanes. जब भी एल्कीन और एल्काइन का रिडक्शन होगा तो वो फॉर्मेशन अल्टीमेटली एल्केन्स को प्रोड्यूस करती है. नेक्स्ट इज फ्रॉम alkyl halide, halogen derivatives of alkyl. Alkyl halide RX. Alkyl halide reacts with zinc oblique dilute dilute HCl. Zinc with dilute HCl reduces alkyl halide into alkane. Elimination of HX and hydrogen get attached here. So formation of RH plus HX. X may be chlorine, bromine, iodine, etc. A real example, C2H5Cl is reduced here. Now zinc with dilute HCl. Here elimination of HCl and hydrogen get attached here. C2H6 plus HCl. Ethane is formed. From where this hydrogen comes? We know zinc has ability to displace hydrogen from dilute hydrogen chloride and produces ZnCl2 with elimination of hydrogen. How it happens? You know, in electrochemical series में position of zinc is above to hydrogen. जिंक की पोजीशन हाइड्रोजन से अबव होती है. That's why zinc has ability to displace hydrogen from dilute acids like H2SO4, like HCl. So this displaces hydrogen, reduces alkyl halides into alkane. That's why zinc is used here with dilute HCl. So what is the use of zinc here? Zinc is placed above to hydrogen in reactivity series or electrochemical series. That's why it has a tendency to displaces hydrogen from dilute acids. This displaced hydrogen reduces alkyl halide into alkane. Next is CS3 CHCl CH3 reduced by ZnCl2 zinc oblique dilute HCl. Zinc oblique dilute HCl. So here chlorine and hydrogen, elimination of HCl and byproduct, and one hydrogen get attached here. Formation of CH3 CH2 CH3, propane is formed. Now next, alkyl halides are also reduced by zinc copper couple with alcohol. Zinc copper couple with alcohol is used to reduce alkyl halide and it converts into alkane. Now same HX and this hydrogen get attached here. So formation of RH. alkane is formed. Zinc copper couple with alcohol is used to reduce alkyl halide into alkane. What is the use of zinc copper couple here? Zinc displaces hydrogen from alcohol. This reducing hydrogen from where it comes? It comes from alcohol, because zinc reacts with alcohol C2H5OH and displaces this hydrogen with formation of zinc ethoxide C2H5O whole twice Zn plus H2 2H. Now here this 2H form 2C2H5OH. This nascent hydrogen, atomic hydrogen, highly reactive in nature, reduces alkyl halide into alkane in presence of zinc copper couple with alcohol. So question arises, the hydrogen comes from alcohol to reduce alkyl halide, because zinc displaces hydrogen from alcohol, gives zinc ethoxide, and the released hydrogen reacts with alkyl halide, and finally alkane is obtained. So the real example is C2H5Cl is reduced by hydrogen in zinc copper couple with alcohol C2H5OH. Now elimination of HCl, C2H6 plus HCl, alkane is formed. This is ethane. Some other reducing agents can also be used here, like nickel, like platinum, like palladium, like Zn/HCl, like lithium aluminum hydride, like sodium borohydride, etc. These all are reducing agents and reduces alkyl halide into alkanes finally. Among these, anyone you may use to reduce the alkyl halide for formation of alkanes. Next is Wurtz reaction. Wurtz reaction, when alkyl halide reacts with sodium, alkane is obtained. Alkane is obtained. Very important reaction in conversion, because from lower carbons to higher carbon compounds are obtained. So this reaction, Wurtz reaction, here alkyl halide Rx reacts with sodium. So 2 Rx are used, 2 molecules of alkyl halides with 2 sodium, elimination of 2 NaX. 2 NaX are eliminated, and now R single bond R alkane is obtained. This is alkane. Real example, CH3Br plus 2Na, CH3Br arrow, elimination of 2NaBr, formation of CH3 single bond CH3 with elimination of 2NaBr. Here ethane is formed. Initially alkyl halide was of one carbon, that is methyl bromide, or IPC name bromomethane. One carbon containing alkyl halide results 2 carbon containing alkane. So इसमें कार्बन इनहेंस होते हैं, नंबर ऑफ कार्बन को इंक्रीज करने के लिए जो रिएक्शंस चूज करते हैं कन्वर्जेंस में स्पेशली, वो वुड्स रिएक्शन उनमें से एक है. Whenever you need to increase the number of carbon in organic chain, then Woods reaction is one among those that are used to increase the number of carbon in longest carbon chain, making the compounds of higher carbon containing. Next, C2H5Cl with sodium ClC2H5, two molecules, elimination of NaCl, so 2 NaCl eliminated, formation of C2H5 single bond C2H5 or C4H10 or CH2CH3 butane are commonly called normal butane without branching. So here just double number of carbon containing alkane is obtained. But one thing must be noted here, if the different the alkyl halides with different number of carbons are used in Woods reaction, then like methyl chloride reacts with ethyl chloride. So what will be the product obtained? C2H5, elimination of 2 NaCl and CH3 single bond C2H5, that is CH3CH2CH3, propane is obtained. But here in this reaction, since it is carried out by free radical mechanism, ये रिएक्शन होती है फ्री रेडिकल मैकेनिज्म से, याद रखिएगा, it is carried out by free radical mechanism. That's why along with addition with different alkyl groups, they themselves get attached and gives a mixture of products like, along with CH3 and C2H5, 2 CH3 get mixed and results ethane with 2 NaCl and 2 C2H5Cl with 2 Na with C2H5Cl, formation of C4H10 plus 2 NaCl. So a mixture of product is obtained whenever two different alkyl halides get reacts with sodium in Woods reaction. A mixture of alkanes is obtained. If we use CH3Cl and C2H5Cl, then the products obtained are C4H10, C3H8 and C2H6. Butane, propane, ethane, 3 are obtained. So it becomes very tough to separate these hydrocarbons among the mixtures because their properties are same. So it is very tough to separate one among the mixtures. Next is next preparation from carboxylics. Acid, from carboxylic acid, in which first is with soda lime. What is soda lime? Soda lime is a mixture. It is a mixture of NaOH with CaO. It is called quicklime. NaOH plus CaO. Why this mixture is used? NaOH with CaO, because NaOH is hygroscopic in nature. What is hygroscopic? It absorbs moisture from air. It absorbs moisture from air. NaOH हाइग्रोस्कोपिक नेचर का होता है और ये मॉइस्चर को एब्जॉर्ब कर लेता है एयर से। इसको ड्राई करने के लिए क्विक लाइम CaO मॉइस्चर को एब्जॉर्ब करता है, मॉइस्चर को एब्जॉर्ब करता है NaOH से। That's why CaO is used with NaOH and this mixture is called soda lime. NaOH plus CaO. Soda lime is used in formation of alkanes from carboxylics. Here NaOH, due to its hygroscopic nature, absorbs moisture from air and it becomes dry due to absorption of moisture from NaOH by CaO. So the reaction is taking sodium salt of carboxylic. This sodium salt of carboxylic reacts with NaOH in presence of CaO quick lime. NaOH CaO quick lime, ये मिक्सचर है सोडा लाइम का, elimination of Na2CO3 and this hydrogen get attached here. So formation of RH plus Na2CO3. Na2CO3. This RH formed is called alkane. It is formed called alkane. RH like this CH3, COONA plus NaOH, CaO. Now elimination of Na2CO3, formation of CH4 plus Na2CO3. Methane is formed. Next C2H5COONA sodium propanoate reacts with NaOH with CaO. Again the same elimination of Na2CO3 with formation of C2H6 plus Na2CO3. One carbon less than carboxylic. The alkane obtained will be one carbon less than carboxylic in this soda lime reaction when soda lime reacts with sodium salt of carboxylic, because one carbon eliminated as Na2CO3, so always alkane formed will be one carbon less than parent sodium salt of carboxylic. Next, next, after sodium salt of carboxylic, next is colbase. Colbase electrolysis. Colbase electrolysis. This is also carried out by free radical mechanism. फ्री रेडिकल मैकेनिज्म से ये कंप्लीट होती है कोलबेज इलेक्ट्रोलिसिस लाइक RCOONA. Now electrolysis is carried out. Electrolysis 2RCOONA 2RCOO minus plus 2Na plus. Dissociation of ionic species is carried out in electrolysis. So add anode. Since anode is positive charge, so negative unit comes here 2RCOO minus with elimination of electrons, 2 electrons, formation of R single one R, 2R are here with 2 CO2. Elimination of carbon dioxide. Sodium salt of carboxylic under electrolysis get ionized, resulting RCOO minus and sodium ion. At anode, negative unit RCOONA comes here. It releases electrons 2R alkane with CO2 get eliminated. So question arises, in colbase electrolysis CO2 is released at anode or cathode. At anode, in colbase electrolysis at anode CO2 get eliminated, escape out. Now at cathode, since it is negative charge, 2Na plus with 2 electrons, and since solution is aqueous, so 2Na and OH, 2NaOH with elimination of hydrogen. So again question arises, hydrogen get escapes are eliminated at cathode in colbase electrolysis. In colbase electrolysis, CO2 eliminated at anode while H2 eliminated at cathode. Since CO2 eliminated in this reaction, that's why colbase electrolysis is a category of decarboxylation reaction. So many questions may arise from this equation. Decarboxylation reaction because carbon eliminated in the form of CO2. So now real example is for colbase electrolysis. Taking CH3 COONA under electrolysis CH3COO minus plus Na plus 2CH3COONA 2CH3COO minus 2Na. At anode it is positive charge, so 2CH3COO minus elimination of 2 electron plus 2CH3, so CH3 single bond CH3 plus 2 CO2 escapes at anode. Now at cathode it is negative charge, so Na plus 2Na plus accepts 2 electron. Solution is aqueous. Now sodium and OH, 2NaOH with elimination of hydrogen. So hydrogen eliminated at cathode. So in colbase electrolysis, minimum 2 carbon containing alkane is obtained. Minimum 2 carbon containing alkane is obtained because here 2 methyl get attached. It is carried out under free radical mechanism. So 2 methyl free radical get attached and results formation of ethane. Methane can't be prepared by this method. Note down it, methane cannot be prepared by this method. इस मेथड से मीथेन का फॉर्मेशन नहीं हो सकता. Next is mechanism of coal-based electrolysis. Here CH3 COONA under electrolysis keep CH3COO minus plus Na plus. At anode, we know anode is positive charge, so CH3COO minus comes here, get neutralized with elimination of electron, and this CH3COO is formed. We can note down this CH3COO like this. In structure form, this oxygen is bonded with only single bond with this carbon. Since oxygen has total 6 valence electrons, so it used only 1 electron in sharing and 5 electrons are left. So here this electron will migrate here at this position between carbon and oxygen, and now from here under homolysis both the shared electrons are taken by both the carbons equally. Homolysis is carried out, and homolysis results free radicals, so here methyl free radical is formed. Now CH3 free radical, methyl free radical plus, and here this electron, and now this under homolysis this electron makes double bond, so C double bond O, or we can note down it like CO2. Here two methyl free radicals, these are highly reactive in nature, get combined and results CH3 single bond CH3 ethane. This is the reaction for anode under free radical mechanism. Next, with Grignard's reagent. What is Grignard's reagent? Grignard reagent is an organometallic compound. What is organometallic compound? Certain compounds where at least one metal carbon bond is present are called organometallic. At least one metal carbon bond is present, so called organometallic compounds like RMgX. This is called Grignard's reagent. Here magnesium metal is bonded with this alkyl, that is carbon metal bond is present. That's why Grignard reagent is an organometallic compound. Under hydrolysis, elimination of MgOHX and this hydrogen attached with this R, formation of RH plus MgOHX, and this RH has general formula CnH2n plus 2, and this is alkane. So whenever hydrolysis of Grignard reagent is carried out, alkanes are formed as final product. So taking one real example, methyl magnesium chloride. Under hydrolysis, elimination of MgOHCl as byproduct and formation of methane. Methane is formed. Next, C2H5MgBr, methyl magnesium bromide. Under hydrolysis, results C2H6 with elimination of magnesium hydroxybromide, and ethane is the final product. So this is all about related to preparation of alkanes. In next segment we will continue about physical and chemical properties of alkanes. Till then, thank you students.